Pre-calculus project, real-world mathematical problem. Kylie Long Math Modeling Project. Mr. Brush, August 26, 2017. Aerodynamic flight in pre-calculus. In this project, I will discuss the use of the basic foundation of aerodynamic flight distance in pre-calculus and how it is applied to everyday life. Aerodynamics is defined by NASA as the branch of science devoted to the study of the flow of gases around solid objects. Aerodynamics is especially important to the design of airplanes which move through the air. The rules of aerodynamics explains how an airplane is able to fly. Airplanes are aerodynamically designed and are built to minimize friction with the air. According to the Dictionary of Science and Technology, flight is defined as the process by which an object moves through the air by generating aerodynamic lift and movement. Aerodynamic flight in everyday life. Essentially, everyday airplanes depart from the airport and arrive at their destination. Los Angeles International Airport, LAX, is no exception. Thousands of airplanes transport passengers to and from various locations. The airline distance traveled can be computed by using pre-calculus. For the purpose of this project, the miles traveled by airplane from the departing location to the final destination will be determined by using the law of sines or cosines. The law of sines. The law of sines is a rule that is used in finding the angles of general triangles. This law is applicable where two sides of a triangle and the angle opposite one of them are given. Therefore, the angle opposite the other side of the triangle can be calculated using the law of sines. The law of sines specifies that the sum of the interior angles of a triangle must be equal to 180 degrees. The third angle can easily be determined. This slide is an example of the law of sines equation. The law of sines equation can also be used in reciprocal form. This slide is an example of the law of sines formula. The law of cosines. The law of cosines is used for calculating one side of a triangle when the angle opposite and the other two sides are known. The law of cosines can be used in conjunction with the law of sines to find all sides and angles. The law of cosines is also known as the cosine formula or cosine rule. It relates the lengths of the sides of a triangle to the cosine of one of its angles. The law of cosines generalizes the Pythagorean theorem, which holds only for right angles. If the angle y is a right angle of a measure 90 degrees or pi divided by 2 radians, then cosine y equals 0, and thus the law of cosines reduces to the Pythagorean theorem. Additionally, the law of cosines is useful for computing the third side of a triangle when two sides and their enclosed angles are known. In computing the angles of a triangle, if all three sides are known by changing which side of the triangle play the roles of A, B, and C. In the original formula, the following two formulas also state the law of cosines. This slide is an example of the law of sines and law of cosines. The law of sines is given two sides, one opposite angle, and the objective is the angle opposite side. The law of cosines is given two sides and one included angle, and the objective is side opposite angle. Rule and cosine rule. The sine rule, A over sin A equals B over sin B equals sin over sin C for finding sides. Cosine rule, A squared equals B squared plus C squared equals 2BC cosine A for finding sides. A squared equals B squared plus C squared equals 2BC finding sides. Real-world pre-calculus problem using the law of cosines and sines. A squared equals B squared plus C squared minus 2BC cosine A. Question A. How far did the plane travel? Bonus question. What is the bearing of the plane? Real-world math problem. The plane leaves LAX and flies 70 degrees south of east for 160 miles. The plane then changes course and flies due north for another 80 miles before turning and flying directly back to LAX. A. How many miles is the third stage of the plane's trip? Round to the nearest mile. B. To the nearest degree, what angle does the pilot turn the plane in order to fly in the next stage? Step 1. Write down the known. Step 2. Apply the law of cosines. Step 3. Substitute. Step 4. Simplify. Step 5. Answer round C equals 89 miles. For this project, I decided to do a bonus real-world math problem. Later that day, the same plane leaves LAX and proceeds on a course 310 degrees for 2 hours at 150 miles per hour. Next, the plane changes direction to 200 degrees, continuing for 3 more hours at 160 miles per hour. At this time, how far is the plane from its starting point? Steps to solve bonus problem. Later that day, the same plane leaves LAX and proceeds on a course of 310 degrees for 2 hours at 150 miles per hour. Next, the plane changes direction to 200 degrees, continuing for 3 more hours at 160 miles per hour. At this time, how far is the ship from its starting point? Step 1. Write down the known facts from problem. The 50 on the right side of the picture comes from a complete circle minus the 310. The 50 in the middle angle comes from alternate interior angles. The 20 comes from the course heading of 200. A straight line is 180 plus 20, more makes the bearing 200. Later that day, the same plane leaves LAX and proceeds on a course of 310 degrees for 2 hours at 150 miles per hour. Next, the plane changes direction to 200 degrees, continuing for 3 more hours at 160 miles per hour. At this time, how far is the ship from its starting point? Step 2. Use the law of sines to find the missing side. The included angle measures 70 degrees. Step 3. Substitute x squared equals 300 squared plus 400 squared minus 2 times 300 times 480 cosine 70. Step 4. Simplify x squared equals 320,400, 288,000 cosine 70. X squared equals 221,898.1987. X equals 471. Step 5. Answer the plane is 471 miles from its starting point. This slide shows a video clip of aerodynamics in flight of a plane leaving from LAX. Conclusion. In conclusion, the law of sines and cosines are used for a lot of everyday life. As shown throughout this project, the use of sine and cosine help to determine the miles an airplane travels and the degree a pilot turns a plane during flight. The law of sine and cosine play an important role in determining a lot of things we use daily. A final page is the works cited slide.